While used, okay. So welcome everyone. I think many people have been on our previous webinars. We are shifting a little bit more to the copper side. We have been talking a lot about fiber testing, and OTDR testing. We're going to go a little bit to another track, copper mainly. I thought we can also talk about fiber in industrial environments. And we have today our guest speaker, Mohamed Abdel Rahman from Trident, the main bandwidth representative in the region. So he will introduce us about all the technical and the background and about industrial Ethernet and what are the standards, what are the topics there you should take into account. And then we come back as Fluke Networks to see how you can test this industrial Ethernet to make sure everything stays up and running. So welcome. I give the word now to Mohamed.
Okay, thank you, Werner. Hello, everyone, and welcome to our today's webinar. Today, Trident Technology and Fluke Network are here to talk about troubleshooting industrial Ethernet environments. As Werner said, we will start the first part with the standards that give you guidance on designing, deploying, and installing of the cabling infrastructure, which is according to the latest standard from the TIA, which is very critical when you are going to the industrial and harsh environment. In the second part, Werner will talk in details about how you can better plan for that.
Mahmoud, sorry to interrupt you. There's some complaint about the microphone quality. Can you double check your mic? Yeah, we can hear you better now.
Okay. Do you hear me now? Sorry, do you hear me?
Yeah, we can do, but try to be closer to the mic, apparently. Sorry for the interruption.
Okay, thank you. As I said, in the first part, I will talk with you about the standards and give you guidance on designing, deploying, installing for the cabling infrastructure according to the latest standard from the TIA, which is critical, as we said, for the industrial and harsh environment. In the second part, I will talk in details about how you can better plan for the system.
Muhammad, also the voice is not clear, so if it is possible, just to try to adjust it. There is an echo in the sound, yeah?
Echo, sorry.
It was fine 10 minutes ago. So.
Okay. Now you hear me clear? Sorry. No.
Still, it's not in good shape, the audio, sorry.
Share your screen.
Yes, that's better.
Okay, thank you. As we said, I will start first with some basic introduction about the designing, deploying, installing for the cabling infrastructure according to the latest standard from the TIA. In the second part, Werner will talk in details about how you can be better planned for your system, how you can evaluate your connectivity and cabling system to support the industrial Ethernet environment. Agenda's first part, we will talk briefly about how the importance of the industrial network and the industrial standard, as we said. One of the main importance that to know that the key difference or key variations between the TIA 1005-A and the commercial building infrastructure standard, which is familiar for all of us, which is the TIA 56A. Finally, the MICE concept and how you can select the product that is suitable to your environment. We will talk in the end of this part. Let's start with the importance of the industrial network to the business it supports. The main important purpose from the industrial network is to control and communicate the status of your profit-making assets. It is very important to know that the industrial network problems are very visible to everyone involved because they can be impact your production and easily to monetize. So the network doesn't cause any problem. The business could be focused on more important tasks. So regarding the network cost distributions for the industrial network, in bandwidth, we found that software consume around 60% of the network project budget, with short lifetime from 2 to 5 years. The network hardware come in the second place with around 23%, and again with maximum life of 5 years. The operation aspects which is related to the network hardware and software are about 10% of the budget. Finally, the network physical infrastructure cabling is only around 7% of the project expense. But we all expect it to last for minimum 20 years. You need to know that half of industrial network problem are the physical layer related. So it's very important when you are talking about the network physical layers or network physical infrastructure cabling. So we need to have some attention to the standards, the best practices when you are designing, implement, operate, or maintain your industrial network. So maybe a few dollars more in your physical infrastructure, we can enjoy the plus 20 years you are expected. So when you are designing or deploying the communications network, it is very important to check the industrial or international and local applicable standard. The standards mean, as we all know, the best practices it developed to have optimum performance for your network. As shown here, you can see that all network standard across the national or international standard from ISO, European, and TIA, starting with the office or commercial building. You are talking about ISO 11801, also the TIA 568-D, which is related to the office or commercial building. For the industrial or plant floor, you are talking about one of the famous standard, TIA 1005. You need to know that when you are talking about ISO, European, or TIA, generally speaking, all these standards are in harmony in most of the critical issues. So this slide shows a network physical layer standard, which is defined by TIA, Telecommunication Industry Associate. For the premises standard, there are commercial standards for the commercial building, data center, healthcare, also as well the industrial solutions or industrial standard. As we said, 1005-A, which is the latest updated for the industrial standard. For the TIA 568-D, which is the latest one for the commercial building, which is define the cabling type, distance, connector, terminations, also the installations and how you can be testing for your cabling. For the TIA 1005-A, as we said, it is the latest updated standard, which is focused mainly for the cabling infrastructure for the industrial facilities. Also, one important to be noted for the industrial Ethernet technology. As we all know that industrial, it is meaning of computer network technology, which is commonly used for local area network or LAN. But when you are going to the industrial Ethernet, there are many protocols used nowadays. When you are talking about the automation system or even real-time monitoring and control application, such as Profinet. Profinet is one of the standard for the industrial. It's called, it stands for the process field network. Also, this one is one of the fastest or faster industrial protocol. Also, the Ethernet Ethernet IP, it means industrial Ethernet protocol, which is uses standard Ethernet frame with the ODVA. ODVA, it is Open System Frame Vendor Association, and the common industrial protocol application. Also, one of the main advantage or one of the main famous industrial protocol, it's called Modbus-IP, which is protocol, is one of the famous protocol used in industrial Ethernet. All these communication protocols are designed for the industrial environment usage for the automations, as we said, real-time monitoring and control. You need to know that that all network components are designed in the industrial network need to sustain the vibrations, heat, electromagnetic noise, and any other industrial condition. Now, this is the structured cabling in the industrial premises, which is based on the universal TIA 1005-A model. Starting from the bottom, you can find EO. EO is standard for equipment outlet. Then as shown, there are 2 or 3 sometimes batching system. It's called subsystem 1 and subsystem 2 up to subsystem 3. Subsystem 3, it's away up to the network core of the network. This is the network core. Also from the bottom, you can find the distributor A, distributor B, and up to distributor C, which is, as we said, the batching collocations for the actual network core equipment. The cabling subsystem, starting from the bottom, when you are talking about the subsystem 1, it's usually, this link can be usually copper. Moving up to subsystem 2 and subsystem 3, sometimes you have usually some kind of fiber based on the lenses or the applications required. In this slide, we will describing some of the main difference and main addition between the TIA 1005-A and the TIA 568. The TIA 1005-A, which is related to the industrial network, you have some additional and some introduction were added, starting with the MICE rating, which is stand for the mechanical, ingress, chemical, climatic, and electromagnetic. And we will discuss in details in the upcoming slide for the MICE rating and how you can be choosing the MICE rating for your environment. A greater, also, the second addition for greater number for the number of connectors, as we said, in TIA 568 only allows for 4 connectors per channel, but now in TIA 105 it is allowed for maximum 6 connectors per channel. Finally, introduction in the TIA for the industrial, it is M12 connector. M12 connector, it is form factor for circular connector. It is around 12 millimeter locking thread used for the sensor, industrial Ethernet in factory automations application. And this connector can have a rating up to IB 66 or 67 up to 68. Also, I will be discuss the M12 connectors and all type of coding in the upcoming slides. Before starting the environment MICE analysis, the TIA 1005 for the industrial identifies 3 different type of areas when you are going to the industrial area or industrial premises. The first area is factory floor. Factory floor, which is high traffic area. As you can see here, the green color, it's high traffic area, and this space is beyond the office and in the manufacturing facilities, and this area requires special considerations when you are going to protection and placement your communications equipment. This area like storage, administration resources, or access floor. So it is typically found in any factory floor. The second area, it is called automations island. Automation island, it is the space within the manufacturing facility, which is close to or on the industrial machine. It is the most harsh area when you are going to the industrial premises. And this area where the human are generally not present in this area during the machine operations. It is not allowed for the human to be inside this area. Finally, the work area. Work area, it is the area within the manufacturing facility where the employee can interact with the telecommunication devices and industrial machines as well. So now the environment MICE analysis. The environment MICE analysis was found in the TIA for the industrial standard, which is provides a environment classification and rating based on the mechanical, which is the first one, it's mechanical, related to the shock, vibration, displacement, amplitude, which may be happened in your area. The second one is ingress. Ingress, it's handling for the water, dust, like IB ingress, which is familiar for most of us, is for the rating for the outdoor environment. The third one, it's called C for the climatic or chemical, related to the temperature and the wash down of the water, exposure to acids or oil mixture. Also the humidity, ultraviolet radiations consideration, all must be considered when you are choosing the right chemical or climatic area. The final one is electromagnetic. Electromagnetic is related to the electrostatic discharge or radiated RF for the electrical noise can be happened in your environment. As shown here, you can have 3 different environment classes. You can be required to choose 1, 2, or 3. 1 for the low concern, 2 you can be choosing for the medium, 3rd for the high concern environment. So now, what is the benefit from choosing the right mice for your environment? The main benefit when you are going to choosing your mice for your environment, that using the mice concept and the structured cabling approach, you can be control your cost. You can be control your cost using the commercial grade component. You can be using commercial grade component as much as possible in your area. As we said before, we had 3 different areas, so you can using the mice can be choosing the right component can be used in your area. You need to know that the environment classification, as we said, for the commercial building, when you are going to the commercial, you can be choosing M1, I1, C1, E1. But when you are going to the hardest environment, you can be using M3, I3, C3, E3, which is the high rate for your environment. So now again, how the mice can be affect the product selection. The first example, when you are going to the pathway as shown here in the table, as mice level goes up, when you are going to from the clean to the dirty or the very dirty area, you can be change the pathway from the hangers up to the conduit or the sealed housing. So you, one of the main factors will be included in your area is the cost of the pathway. You need to choosing the pathway based on your environment mice level. Also, when you are going to the ingress for the category I in the mice, for the less hazardous environment, you can be using the standard grade from the patch cord or even for the cabinet, which is standard for the environment. But when you have hazardous conditions, the component used will have some to be need to have survive your and perform 4 years. So you need to choosing, for example, batch cord, which is IB67, or sometimes you are going for the industrial grade equipment like NEMA type 12. It is the indoor cabinet, but have a high grade for the dust and the protections from the dust or water or liquid inside your environment. As we said, the mice standard is used to rate the environment. We are not talking about the product now. You are rating for your environment. Each product used in the system design should be at least equal or exceeding the mice evaluations for your space. So as you can see here for the drawing, there are 2 lines, the blue line and the green line. The blue line, it mentions that point-to-point cabling, or in another way, it means single cable can be used for all area. When you are going to design, you can be using 1 cable traverses for multiple area, which is not required because it will have high cost, because the cable need to have meet all requirement for all area. For the green lines, you need to have structured cabling. Structured cabling, it means that each cable is restricted to given the area. When based on your area, you can be structured this cabling and using it based on the environment. So it means you having saving your cost, not having same cables in all environment conditions. This is the example for the mice when you are talking about the food processing, packing and distribution. This example, you can be choosing the suitable environment mice rating from the blue choice. You have 4 blue choice when you are rating this environment, which is called food processing plant. I think first you are going to the mechanical. I think you need to choose the M3. M3, it means that you have some vibrations in your area due to the automated equipment and motions for your equipment and package moving inside it. Also, you have 2 conveyors intersecting here in your area. So you needing to choose the highest mechanical. So the first one, you need to choose M3 for the ingress and the chemical climatic. I think this area it is for the food processing, so no mechanical contact, or you don't have any temperature varying or variations inside this area, because it is food processing area. So you can be choosing it I1 and C1. Finally, the electromagnetic, you need to choose it. It is industrial area. So you have electromotors. So you need to choose E3. E3, it means that you are going, due to the medium and the high voltage included in your area, you need to choose E3. So the right solutions for our right answer for your for this example, you need to choose M3, I3, C3, E3, which is suitable your area. Suitable your area. Okay. The second introduction and the addition in the TIA 1005 standard is the M12, M12 form factor connector. The M12 connector is a circular connector, as I said before, with a 12 millimeter locking thread. It is used for the industrial Ethernet communication when you are going to the automations application with a higher IP protections rating. It can be up to 68, 9 or 68. You need to know that there are many M12 coding types starting from A, B, D, and X. For the type A and B code are not suitable for your Ethernet communications, but when you are going to the D and X code, the X code, it's commonly used in industrial Ethernet nowadays. So the difference between the D code and X code, D code as shown here, you can be connect up to 2 wires, 2 pairs. 2 pairs, it means you have 4 position, so you can be connect 2 pairs of cable. So you can be transmit up to 100 megabit per second for the Ethernet. But when you are going to the X coding, X code for the M12, it is used for the 4-pair cabling. It can be transmit up to 10 gigabit per second for your Ethernet. And in bandwidth, we have the field terminal, terminal plug. It is an industrial net for the M12. You can be using it. It's very simple to connect it, like the field terminal plug. We said it before for the Ethernet or for the commercial building. But here you have a high protection and it can be using for your automation system. The main difference, as we said before, between the D code and the X code, D code can be transmit up to 1 megabit per second. You can be using it with the 2-pair connections. But for the 4-pair connection, is familiar for all of us. For the 4 connections, you can be using the X code. It contains 8 positions, so you're having 4 pairs can be connected inside it. Okay, now the E factor or electromagnetic interference is another key factor or key area. It is very important when you are specifying your cabling system. So to avoid your electromagnetic interference in your area, there are many factors when you are choosing the cable you need to examine. The first one, the electrical balance of the cable. It is very important. So, sorry. The better the electrical balance of the cable, you have the more protections from the electromagnetic interference. Then the second one is the shielding. The shielding is very important when you are going to the electromagnetic interference. So you need to have the protection against noise, different cable shielding starting from UTB up to SFTB can be shown here in the diagram. Also, to avoid the electromagnetic interference, you can be using fiber optic cable, or you can be using separate pathways for your cable to avoid any electromagnetic source. So now this is example for the shielding solutions from bandwidth to protect you from electromagnetic noise mitigations. So at the left, you can see here the patch panel, which is using it for the grounding and bonding. The shielded cables also for the jack and the plug in the top right. Also the cables, we have different cable for 600 volt rated. This cable, it is shielded cable and can we have it for the patch cord also. You can be, this cable, it is upgraded with the jacket installation. Which is stand for the high voltage and providing you cost saving by avoiding any need for separations for the cable, as we said in the previous slide. So you can be using this cable. You have different range from the cable 600 volt or 300 volt. Also the shielded wiring duct. This duct can be providing additional protection from the noise producing source. Okay, now The final topic, I will discuss the structured cabling versus the point-to-point or home run direct connection. One of the important factors when you are going to consider and designing for the cabling, the structured cabling system. We need to build cabling with systematic way. You need to be predictable, standard compliant, and easy to be upgrading. And you have Mac. You have move or add or change. As you can see here in the right, this is diagram for permanent link, jack to jack, or patch panel to patch panel. Maybe patch panel may be terminated in the control panel, and another side in the data cabinet. Also, you can be using jack to jack, and the flexible patch cord can be using from both sides. The same concept you will be find in the industrial for the input-output and terminal strip. That is manage the controller through, as you can see, the terminal strip and the IFM interface module. In industrial, they are using the structured cabling also as well. The point-to-point cabling or home run cabling, you can be using it for the cabling subsystem 1. As we said before, the cabling subsystem 1, you can be using to connect the machine. This method, it is not scalable for the plant-wide. And you can be, you need to using it conjunction with the structured cabling. So as also the test, one of the main factor when you are choosing structured cabling or point-to-point, the point-to-point have limitation when you are going to the testing and the troubleshooting. So you don't have any standard exist to define the measurement method versus the structured cabling system, which is included in the manufacturing warranty. So now, this is the summary review. You can review the steps, can be used for designing and deploying for the industrial environment. First, you need to study the future growth of your plant to take into considerations before you are starting for the design. As agreed, based on the TIA model, you have 3 subsystem connections. You can be having subsystem 1 cabling, 2 or 3, can be using it for the M12 for the automations machine, also the copper and fiber as well for the high lenses can be used. Also, you need to know that you can be installed up to 6 connectors from the copper per channel based on the TIA. Then the usage for the mice rating. Mice rating is very important. You need to rate your environment as shown here. Each area you can have its own rating. You can be choosing the rate for the area, as you can see here, different rating for the area. Finally, the product selection. When you are getting the area rating and the mice rating for each area, now you can be finally get the product. As shown here, Bandwidth have selected or selection guide, which is provide industrial physical infrastructure designer with the details of the mice. You can be found here. Each product have the details of the mice information on each product. So the guide, this guide list can be help the designer. So you don't need to learn more about the physical properties for each component, as long as it comply with your mice rating or not. So all details about the component can be used in your design. You can be found in the mice guide. You can be downloaded it from bandwidth.com/mice guide. This is very important. So now let me briefly restate the main points discussed in our first part. We discussed the TIA 1005-A industrial premises standard for the ICT. Also the concept for the mice rating and dynamic on the plant floor. We talked about applying the structured cabling from the industrial to control panel. Finally, we discussed the mice rated product selections for the plant floor. Now, thank you for your time. If you have any question, drop it in the chat box and I will be answering it. Thank you.
Thank you, Mohamed, for the introduction and to have us understand what mice means, that it are not cat and mouses, but mice ratings. So, so let's now have a look on how we are going to test all of this. my video if you want to see me. And I'm going to use the laser pointer. So that's a good one. So how to test now this industrial Ethernet? Little word about Fluke Networks, but just to share with you, we are part of a family, and there is a division called Fluke Industrial, Fluke, which is in industrial environment, but measuring the rotation, power quality, voltage, current, etc. So we do have some experience, let's say, from the industrial environment, but the Fluke Industrial, they don't really have cable testers. So we still are, as Fluke Networks, we will provide or can provide cable testers, beside all the other opcos, and that may be seen in previous webinars. We had one on healthcare system. So what are the benefits of industrial Ethernet? Can give you faster speed, larger data volume, large different applications. You can run different protocols on that same cable, harsh environment, the MICE qualification, as Mohammed has explained, but also the power you need to provide to some of the devices, and you can have a broader temperature spectrum for industrial Ethernet environment. Now, what we see and what we hear back from different customers and industrial environments, that you see here, if you take the pie chart, that there could be issues in configuration devices or the software or noise affecting the communication to the different devices. But in almost 50% of the cases, the issues are coming from the cabling part. Connectors are not correctly dimensioned, or not the proper quality, or not the proper MICE environment being chosen. The length not correctly dimensioned. We will see what is the effect of temperature and others on the length, or just a cable type which is not properly used. So almost 50% of the issues are coming back to the cabling. So that's why it's very important to do the testing of the cabling. This is a slide, yeah, should be recognizable now from what Mohammed explained. If you have an office environment, you specify here the MICE 111, so there is not too much influence on mechanical or chemical or electromechanical. But if you go deeper into the plant environment, there could be more challenges on having the right cable being in place, based on electromagnetic influence of engines, motors, for example, or heat or other influences that can happen on your cabling. So how to reduce cabling issues? Mohammed has already mentioned several of these, using proper connectors, using the proper cable. If there is heating possible, use a thermal resistant cable, the typical RG45, but then for better water resistant environments, the IP64 version, or the industrial connectors, the M12. But you will see what is then the challenge to connect now to your tester, because we are used from the enterprise environment to use the RG45. Use Ethernet cables, test them, verify them, certify them, qualify them. Verification, if you remember from previous webinars, having checked this, if there is no short circuit, check if the pairs are correctly connected, wire map fine, length. Some devices can measure the length already, or go for certification that gives you a better knowledge of, or better understanding what is the quality of the cable before you start running your applications over it, even in industrial environment. Just it's always good to have guest speakers, that it's not only Fluke Networks who is telling you something, but this is from industry and this is general. So we are here telling the same. So Mohammed explained to you the TIA 1005A for industrial environments, where we are used TIA, the Cat6A standard. So Similar parameters, but slight differences for industrial environments because of different connectors, different cabling parameters, different cable types, and then the protocols which are running on top of it. Also, Mohamed mentioned them. They are a little bit pushed through the different manufacturers. Mentioning names, the Siemens, the Texas Instruments, they each have their own systems, their own protocols running over that cable, but they could have also their own guidelines on the cabling that is being used. So when should you validate, when should you test the cable? Well, you can do that in the different phases of setting up a production or during production, or at a moment when things start failing, start falling apart. Hopefully not, but so before you start, you set up the production. During the assembly, there can already be done some cable testing, like the wiring, make sure the twisting is not too much, that the shield integrity is there, that there is no damage during and after the installation, that the cable lengths are correctly dimensioned. During the installation, you can do some testing, that the cables are not being broken during the pulling, during the installation, that the connectors are still properly installed, that there is no signal loss during the installation. And after, when everything is in operation, you could maybe, when things are not working anymore, do troubleshooting to reduce the downtime. Imagine you have a bottling company or whatever industrial environment. You can understand if the production stops for a few seconds, a few minutes, how much revenue at the end on products you cannot produce, you cannot sell. So it's a huge loss for the plant if production is coming to a halt. So it's good to have the right tools. You see a typical setup here for testing the cable. We'll come back to that, how to test, what to test there. Reducing the downtime, as I just mentioned, could be very costly. Yeah, machines can fail, heating, chemical, things, chemical ingredients could flow over, or water gets into the cabling. So this could harm the cabling and could even stop production if the communication is not working anymore on that cable. Here you see some overflow of chemical products. If that hits the cabling, if it's not properly dimensioned, your production stops. So you need to have the right dimensions, the right configuration of your cabling in place. That's why you should test your cable from end to end. A little bit different than enterprise environment, where you remember permanent link, that's what stays in place, but you still have your patch cords and your equipment that comes. So in industrial environment, it's more important to test really from end to end. So which cable testers you can use? You see here, we are from Fluke Networks, our typical DSX 5000, 8000 can be used, not only for the TIA 568, the Cat6, Cat6A, Cat8 testing, but also for industrial environments. So the same tester can be used, but you will see maybe with a different connector that you have to use on that same tester. So we can test against industrial Ethernet protocol standards. We can show that it passes all the parameters, but also when it fails, you can then quickly determine, is it a connector, is it a cable, is it the joint somewhere, what to test, what to change, what to fix, instead of bypassing the whole cabling to get things up and running. Remember, a few minutes downtime of production can cause millions of loss of product that you cannot sell. You can also do some verification, check wire maps, check the continuity, check the bandwidth qualification on the cable before you do full certification, or more for the troubleshooting part. This is a typical example of a solution for industrial Ethernet. As you maybe recognize, the DSX 5000 or 8000, but these specific adapters for M12D, M12X, as Mohamed explained, how they are configured internally for this industrial environment. This is the order reference. On the verification side, we have the microscanner POE that can help you to show length of the cable, but you see here also wire map issues. Here, for example, 3 and 4 is being crossed. It's not showing you on the diagram, but you can see it on the wire map. Here you can see a short circuit on some cable, or if the shielding or some open on some wires or on the shield in this case, it can show you this type of errors already on the cable. To come back, Mohamed mentioned already permanent link channel that we take over from the typical enterprise environment, but for industrial environment where we use now the M12 typical connector or other industrial connectors, and you can have now up to 6 connectors, as Mohamed also mentioned. So now you should measure from end to end. So as a little refresher, so permanent link is what is used in enterprise environment, what stays in place because you don't know yet which patch cords will be used, etc. So that's a typical Cat6, Cat6a installation testing. That's a permanent link test. At the end, when the equipment is available in enterprise environment, you can do a channel test, but per definition, the connector is not included in a channel test. Now, in an industrial environment, you need now to test or include also your connector, your M12, your special RG45, M12X or D, whatever. You need to include it, so you need to do an end-to-end test. This test is then available in the test. This is a typical setup. You go here to M12 connectors, the special adapters on your tester, M12D, M12X or RG45. And then in the tester, you can test here your 2 connector, 3 connector, 4 connector, and then the mice environment. Remember the 3 levels, E1, E2, E3. And then according to the specific standard, ISO or TIA, you can select here the specific test for different setups. These tests are available. It's not another software in the DSX. They are there. You just need to have the right connectors, of course. You see all the industrial standards that you can select, TIA, ISO. We will come back here to the POE test. We will have a little word, or the plus all, where you will do the TCL and the EL TCL tests. We come back to that. Electromagnetic interference, how to avoid that. Also there, Mohamed mentioned already, use the right connectors, shielded cables, special connectors. Make sure shielding is used and connected and properly connected. We will come back to that, how to test it. Eventually use optic fiber. We will not spend much time today on fiber testing. We have done many webinars before on fiber testing. That is similar procedure. Do the loss length testing or an OTDR test, or just a verification with a VisiFold or a simply fiber. Use high balanced UTP cables to avoid electromagnetic interference. We will explain that a little bit deeper. And another solution, maybe better solution, is routing the cable away from your engines or motors that can have or can introduce electromagnetic interference. But of course, you need to check or take into mind that hey, the length should not become too long, because then again other parameters will start playing, like the temperature, for example. Here you see the different connectors again. As Mohamed already explained, M12 decoding, M12X coding, how the TIA or the different application layers, Profinet is specifying the connection here. So the tester is doing, like in an RG45, doing the wire map test, but also show it here then on this M12. Because on RG45, you know, maybe, hey, the wire 1 is on the left and the color coding. In a round connector now, it's not that simple anymore. Yes, there are some dents or some other indicators to show where to start counting the 1, 2, 3, 4. But yeah, which direction? Is it circular or other direction? So could be confusing, but our tester will then tell you, is the wire map correctly done for this industrial end-to-end connection. Here are a few examples of miswired cables, open pair, a flipped pair, shorts, crossover, and a split pair here. So this will be shown on the display of the tester to tell you exactly what is wrong on that cable. Typical question you always get, what, for example, if you have a flipped or a split pair, on which side it is? Of course, yeah, it can be on you have to change it on one side to make it correct again. There is no specific side, but if it's broken, it will tell you at which location it is broken. Then you can know, is it on the main side or on the remote side. The shield quality, very important, especially in industrial environments, to avoid electromagnetic interference, as we have just seen. So it's very, very important to properly measure the shielding. We could do a demonstration, but that would take some time. It would take several minutes to show you, but we try to convince here. You see here on the picture, you have here shielded connectors, and you keep them even close together, so they touch each other. So there should be connection. If you would measure that with a multimeter or even with our old DTX, it would show that there is a closed connection, short circuit to the connectors. Strangely enough, if you would test this, and because there is a professional miswiring done, the shielding is open. So try to understand this setup, that you have the connectors are connected to each other. Yeah. So you could say, hey, this must be, the tester should here show a short circuit or that they are connected. They are not, yeah, because of a quality issue or unstripping, or the shielding has been disconnected from the shield on the cable to the shield on the connector. Looks all, yeah, maybe a little strange and why this is, but this is very critical, very important. So we have the special technology in the unit. How exactly it works is a kind of time domain reflectometer on the shield along the cable, as per the specifications of the standards committee, that we do that measurement. Take any other tester in the market, if you do this type of test, they will show the shield is fine. Yeah, guaranteed. A few other parameters, maybe it's a little bit technical, but I think good to refresh a little. Signal strength is important, and you will see, we'll come back to that. Signal strength, what is it? You inject a signal on one side, you measure how much power or signal is left on the outside, you divide it by each other, a logarithmic scale, etc., and you get a graph. There could be signal loss could increase in function of the length. The longer, you can imagine, the longer the cable it is, the more signal strength you will lose, or if you use a higher frequency. But also what is important, you see here the temperature and the wire gauge. If you use different wire gauges, could have an effect on the signal strength, but also temperature. Because in enterprise environments, in an office environment, you will see the standards are specified on 20 degrees Celsius, which gives you the typical length or limit of length, 90 meters for a permanent link. But you can now imagine in an industrial environment, if there is some heating up or other factors that influence the cabling, so specifically now for temperature, you will have an effect on temperature. So if the temperature increases, let's say to 50 degrees, then you can have for unscreened only 80 meters, for screened cable only 85 meters instead of the 90 meters. So you're losing almost 5 meter length distance on your cable. So this is something you have to keep in mind. We come from the enterprise, we have in our head, oh, permanent link, 90 meter. You install 90 meter cable, but then in an industrial environment, higher temperature environment, you cannot use the 90 meter anymore. So you will lose some distance as the temperature increases. So very important to keep that in mind. And no, we don't have a temperature or a thermometer on the unit to take that into account. So this is something you have to check on the tables, but we do that a little bit then with the mice parameters. No, not really. So next, another parameter is noise. Next is in principle noise within between the pairs within the cable. You put a signal on one pair, and there could be noise because the cables or the pairs are very close. They are in the same cable, so they are close to each other. So you will have some noise to the other pair, and that gives you a wrong signal here on the output on the same side. That's for next. Next is then on the far end. So you have to measure that, especially again in electromagnetic interference environments. This could even affect, if you have noise from the outside, could even affect that next crosstalk within the cable. You can imagine if you, by twisting, you see here one pair of the cable, you avoid that, that there will be noise going to the other twisted pair. So you can imagine if you untwist the pair too much, of course, you will have more noise going to the other pair, especially on connector side. So crosstalk could have an effect on the connector side. So it's good to measure that. Here you see a graph of your next of all the different pair combinations against the limit, and that is a clear path for this next parameter. Noise, return loss. It is the signal that you sent over the pair and what is bouncing back, let's say, to the same side. So this should not be too high, otherwise again you have a wrong signal. So you have to measure this return loss. This could happen, bad quality of the cable, damaged cable, again a poorly matched plug and jack, poor quality just mentioned, not only cable but connectors. So this could have an effect on your return loss of the cable. This is a typical measurement. You see the graph here for the different pairs, the limit, and in this case it is a pass. So you can test this before or during the installation and after the installation that this is properly done. Resistance unbalance. For those who were on the webinar around PoE, maybe you remember that for the CCTV cameras and the wireless access points, you should have a well-balanced cable. What do we mean with that? That the difference in resistance between the different wires should be very minimal, because if they are too much, there is a resistance unbalance, what we call, and you cannot transmit the power properly to your sensor, your wireless access point, your access card, reader, whatever. So that should be in balance. If it's too much out of balance, this will cause a fail, especially if you need power over Ethernet, but also for other reasons, retransmissions, the machine, the control software will not work properly. You have to retransmit the data again and again. So it's good. It's that you measure that resistance unbalance during, again, installation, testing, and at the end of your production setup or machinery setup. Electromagnetic interference, the E in the mice, as Mohamed explained. So to get a better indication if your cable is of good quality, if it can resist E1, E2 or E3 level, you should measure the TCL or the ELTCL parameter on that cable. A cable who does not have a good quality could be more affected or could get more influenced by electromagnetic interference. So if there is a motor or an engine or a machinery or other waves that could influence that cable. So if that cable is not well properly dimensioned or from a lower quality, this could influence your data again. You will have wrong signals, wrong data going through your control panel. Machines will stop or not correctly work. So what is TCL? Here is the explanation, if you want. It's the transverse conversion loss as the ratio of a common mode voltage measured on a wire pair relative to the differential mode voltage applied to the same end of the pair. You see here how this is done. We measure that. It's a very complicated measurement. Again, if you want to buy a tester for industrial environment, make sure you can do that TCL measurement, because we don't know that many testers who are doing that TCL or ELTCL measurement, because you see it's getting very complicated to do this type of measurement. It's on low impedances. Here you see a typical graph of the TCL, and you see here in this case it is exceeding the limits as per the standard. It's not a requirement, but you can test it, and there are definitions and limits for it. In this case, it gives a fail. So this can indicate that the quality of the cable is not that high for several reasons. People want to buy cheaper cable, okay, but be aware this could have at the end an influence on your production system. Here you see the tables or the standards that define the next and return loss, power sum next, but also TCL and ELTCL for the different frequency ranges on a specific standard, let's say. Here, D5 connection, E3 level in the mice for ISO 11801, yeah, different standards, and we have all these tables, and they are entered pre-entered or configured into the tester. So if you select that standard, it will test against these limits for all the different frequencies. And at the end, of course, good to have that documentation of your cable to avoid the finger pointing, but to make sure you have this high quality cable in place, that everything is properly connected. We have done a specific webinar about how to read this report. So very briefly, of course, the main thing you want to see is your pass fail. But yeah, is it just a PDF, or do you have all the underlying data? Which test limit you have used? Is it a proper, if it's for industrial environment, is it an end-to-end test for the right mice parameters? Which tester have you used? Is it calibrated? Which adapters you have been using? Was the firmware the latest? Has the shield test been done or not? If, especially in industrial environments, more and more shielding should be used. So it's good to have a test report of all your cabling from your machinery to make sure that everything stays up and running, and that you will not have too much or not at all any production downtime. That's it. That was a little bit around our industrial Ethernet, so very close to the enterprise Ethernet, but these new parameters, mice, different connectors, you have to measure end to end. Take into account that temperature could have an influence on the length that you can still use on your cabling. Don't have time, but we also have, of course, fiber testing, or we can do fiber testing. Fiber is used also in industrial environments for several reasons. Less electromagnetic interference influence, longer cable, more data, more higher bandwidth, etc. But then you have the other side is it's more sensitive for dirt, especially in industrial environments, more dirty environments. So again, you need to test. There is not that very specific things to test, different than from an enterprise environment. Loss length testing, OTDR testing to see if there is an issue, where is the issue? Is it the connector? Is it the splicing? But that's what we try to explain. Hey, different new things on industrial environments, and then what to take into account or what to pay attention for during the testing. Plus, we have the equipment available not only for enterprise but also for industrial environments. Any questions? Looking at my colleagues, was there anything specific or?
Hi, Werner. Yeah, so a question that do we have a specific model with Fluke networks that it's used for the industrial testing?
Yes, I thought we showed that in the presentation. So on the tester side, so this is a model specific for industrial environment. So it's ESX2, you see maybe a 5 from somewhere from the 5000, but this is then industrial Ethernet and kit 1. So this is an example. There are different kits we have predefined. What is a big difference? Because you don't have this permanent link. It's not an enterprise environment, so you do not see a permanent link, for example, but you see several industrial adapters, the M12, D and X adapters that then come with the kit. And you can add again fiber modules if you have fiber in that installation. Yeah. This is a typical specification tool for industrial environments.
Yeah, there's another question. Is there any standard range for acceptable next headroom? So yeah, I think because they mean that is it different than what the limits are different than the commercial?
Yes and no. So some parts are the same, but if you go, remember the mice parameters, then there could be some differences on the limits for some parameters. So this is, I think in mice 3, if you would compare with mice 1 or mice 2, there could be changes or differences on TCL or even next. So yes, there are differences on the limit. It's not much, but there are small differences. Yes, there are differences.
Yeah.
Acceptable headroom. If it's passing, it's passing. The more headroom you have, the better. But yeah, once it passes, it's okay.
Yeah, a question for Muhammad. So I think you answered it, but it's nice to share it. What's the maximum data rate we can expect in an industrial control system? So Muhammad, are you?
Yes, it's based, as we said, it is based on your cabling from both sides and your active also. So I think it can be up to 10 gigabit per second when you're going to the automations and using the M12 code we set.
Again, Muhammad, we are having some issues with the voice. Yeah, so.
Okay, sorry.
Yeah.
Is it clear now?
Yeah, it's better. Yeah.
Yeah, okay. It's based on the cabling from the both sides and the total solutions. When you are going to the Cat 6A, you can be support up to 10 gig. And for the automations also, when you are using the M12 code, it can be support up to 10 gigabit per second.
Okay. Yeah, it was not very clear, but I think you answered it.
Yes, I think. Okay.
Okay. Yeah. So. Any more questions, Wael? Yeah, a question, can we support also fiber in the industrial environment? I think, yeah.
Yes, I mentioned it, but that we don't have much time in it. Yes, of course, fiber will be supported in industrial.
Okay. Yeah, I think that's all. That's most of the questions were answered. So yeah. So thank you, Muhammad. Thank you, Werner.
Yeah.
We would like to just to finish it, Werner.
Yes. So thanks everyone to join our webinar again. As we said, it's a little bit maybe a sidetrack, but and maybe less production in the region here in the Middle East. Maybe although we see food production. Drinks are bottled here. We don't see much car productions in Middle East, but we see that in African regions, South Africa or in Turkey, for example. So maybe less applicable here, but also in oil and gas, for example, we see that's also industrial environment. So yes, we wanted to show that, hey, there are some things you need to take into account. It's not an office environment. There are different temperatures, there could be engines running that can influence your cabling system. So be aware, there are standards for industrial environment, that you use the right standards, that if there are different connectors being used because of the industrial environment, that you use these connectors and test from connector from end to end by using the right connector and using the right tools. And of course, as Mohamed explained, make sure you specify the cable properly, have quality cable being used, quality connectors to take all these external influences into account.
Okay. Yeah. Thank you very much. Thank you, Werner.
Thanks everyone, and looking forward for next week.
Thank
for
you.
Those who still needs a fiber tester, we are ending in a few days till 26. Special fiber promo prices. So was extended with 2 weeks, but now it's definitely finished on Friday. Next week, I think, while you will do fiber basics, we got some feedback from a lot of people. Hey, we want to see a little bit more, again, technical. How is the testing exactly done? So we will go again layer lower and do some more in depth on fiber. Maybe we have to split it. We want to keep it on 1 hour, but that we have different parts then, but really go a little deeper. Yeah.
That's
Thank
correct.
you, everyone.
Yeah, thanks.